Sure thing, sure thing. Thank you very much. It's great to be here. I love Sneak. I love DevSecOn. So thank you very much for having me here. So today we're going to have a very short and sweet talk about Kubernetes schema validation and why is it important and what are the practical tools that you can use in order to actually validate your Kubernetes manifest. So without further ado, I'm Shimon. I'm based out of Israel. I'm the co-founder and CEO of Datree. I'm an AWS Community Hero, and I also lead the CNCF chapter here in Israel. So I get to see a lot of Kubernetes here. A little bit about us. We're an open source project at GitHub. We just passed the 5,000 stars mark, so we're very, very excited. And we can help you prevent misconfigurations from happening in your Kubernetes. And we also embrace the shift left movement, exactly like Sneak, and you can run our CLI tool in a shift left way. It is very easy, and we encourage you to check out our open source project and also commit to it. And why am I telling you this? It's because we get to see a lot of organizations that are using Kubernetes and that they have the DevOps and SecOps people working together with the engineers. And when you start to use Kubernetes, everything's nice. The sun is shining. You're using Helm. You're using Kubernetes. Everything's great. And now you're starting to delegate infrastructure as code responsibilities to developers. And then, it starts out nice, but at the end of the day, it's not always a nice rainbow. And sometimes you might have production outages because, the best Java payment engineer might not be familiar with all of the development standards and policies that you want them to do. And this is why I believe in tools like Datree and Sneak and others that help you bring security and operations shift left and help those people prevent the issues from happening. So why do you need to run schema validation for Kubernetes? So when you write your Kubernetes manifest or Helm charts, you then compile it, like in a way you build it on your computer and then you send it to your cluster. And with sending those changes to your cluster comes a lot of challenges. Number one, you want to be able to understand the problems from the get-go, from when the manifests are actually written, and not at the end just before they are applied to your production. And secondly, you don't want every developer to have direct access using cubectl into your Kubernetes cluster. But on the other hand, if you have custom CRDs or other Kubernetes resources, they need to have it in order to validate their schema. So today I'm going to show you a way where they don't have to have access to production and where they can find and fix the problems that they have on their side. So we're going to talk about 4 methods to achieve schema validation while building Kubernetes files. So we're going to talk about Cubeeval, CubeConform, and we're going to talk about cubectl or cubectl. You call it as you want. Everyone uses different types of names. And we'll talk about client mode and server mode. So let's start with what's wrong with cubectl. I have cubectl. I'm using it. Like, well, what seems to be the problem? And the problem is that if you use a dry run in order to check your manifests, and if you use it in a client mode, then you're actually not checking it against the real, Kubernetes cluster. You're not checking against custom CRDs, and it's a kind of a dry run that does not represent a lot. On the other hand, if you use cubectl in server mode, I think it's the best check. The problem is that when you do that, you actually need to have access to your production cluster. And then you don't want to have direct access to your Kubernetes cluster from every developer's laptop. So it brings a challenge. So for that, there are solutions, and we'll talk about 2 solutions today, Cubeeval and CubeConform. And now, I'm not to say that cubectl by itself is not good. It is very good, and you should use it. It's just that I think that you should apply additional checks prior to actually using just that. My robot cleaner decided to start cleaning the apartment now, so I'm gonna turn it off. As you can see, it is not recorded. Great. So let's dive deeper. So what is Cubeeval? So Cubeeval is a great project. Again, it's open source in GitHub, and it's a tool for validating Kubernetes YAMLs and JSON files. And what it does, it actually uses the Kubernetes Open API. It fetches all of the Kubernetes API specification, and then it checks the manifests against this schema. Now, it is a fairly popular project. It has 2.6 thousand stars, but it is not very actively maintained, and it does not support custom CRDs, which is very, very popular today. So I'll just go over the different tools, and then I'll show you a comparison. Next, we have CubeConform, which is a very great guy called Jan, who saw Cubeeval and said, this is a great project, but I want to improve it. And he invented CubeConform. And it is inspired by Cubeeval, but it is maintained more frequently. And it also contains some additional aspects. So it has high performance in order to validate your manifest. So it uses multiple routines to catch and download all of the information, which, if you have a large cluster and a lot of workloads and so on, it can take a lot of time relatively if you're doing it with just Cubeeval. A very important capability is that it configures to run on local schemas and validating CRDs and offline validation capabilities. So it provides you the capabilities from runtime actually in your dev environment, which is really, really powerful. And it is really nice because it is up to date to the schemas, and it is very, very maintained. So as opposed to Cubeeval, they actually every new version or subversion of Kubernetes, they update the manifest, they use the Open API to catch it, so it is really up to speed. So let's talk about the comparison of those tools. So I put in on this table Cubeeval and CubeConform, and I put in the CubeCtl dry run using client and server mode. So, and there are several use cases here. So one of them is API deprecation. So all of them will catch it. Invalid kind value, will catch it with Cubeeval and CubeConform, but client mode won't catch it, and server mode is I won't go over all of them, but I think that one of the most important thing to see is that most of the use cases are covered with CubeCat and CubeConform, and they are able to run on all of your developers' computers and CI/CD. Maybe I'll say CI without CD, without connecting to the cluster. So it has a very, very high impact. Secondly, we can look at the comparison of the tools in terms of how long do they execute. So some of our customers, they have large clusters, and they have a lot of resources and a lot of files. So here you can see that CubeConform on 7 files, the mean time was 0.2 seconds. Cubeeval took 1.4 seconds, and CubeCtl local took almost 2 seconds, and CubeCtl server took like 2.2 seconds, which makes sense. Let's look at a deeper comparison, which is against 100 files. So again, CubeConform was very, very fast, 0.3 milliseconds. CubeCtl server mode took 1 minute. And now, of course, this may vary depending on your Kubernetes cluster and how long does it take it to connect to it and so on. So it makes sense. Another comparison that I can show you is the 4 types of schema validation that you can make. So misconfiguration coverage, benchmark speed, Kubernetes version support, and CRD support. So I think that as you can see, the results vary, and you can choose the ones that are more important to you. So coming to the final notes here. So what are the different strategies that I believe in terms of validating a Kubernetes schema? So number one, shift left. You should run schema validation as soon as possible. And of course, you can run dry run server on every code change, but it's not feasible, right? You have 100 developers, they're not all going to have access to your cluster. So run a shift left, use CubeCtl or CubeConform, and don't avoid using cubectl server mode. Just run it in your CD process before the end. And as we know, things that happen at the end of the process, the developer already forgot what they were doing and already doing something else, and then you need to context switch and so on and so on. Secondly, CubeConform does not cover all common misconfigurations, so you need to also use some kind of policy enforcement tool alongside with it. It can be sneak infrastructure as code, it can be Datree, it can be other solutions, but it will not cover all cases. It will just focus mainly on the schema validation. And then comes the question of, buy versus build. So you might ask yourself, okay, maybe I can take like CubeConform and take ConfTest, which is from the open policy agent ecosystem, and it can be a great combination, and I can start writing my tools, writing my tests. Of course, ConfTest comes with 0 tests built in. Garrett, by the way, who works at Snyk, is a great guy. He wrote ConfTest, but it does not come with predefined tests, so you need to write them and create them. Or, of course, alternatively, you can use out-of-the-box solutions like Datree or like Snyk infrastructure as code. And, of course, the keys are provided. In addition with Datree, we run CubeConform as part of Datree. So like you get 2 in 1. So this is something that you might consider. And finally, I'll say, don't forget to use cubectl server mode in your CI, CD, or I should say the second before you ship it into production, because again, it is best to have several checkpoints. And I do believe that checking on the CD side is also very important. And finally, there is another option, but it takes a lot of overhead, is you could technically take all of your manifests, run a mini cube on your laptop, and run a CubeCtl server mode. So you could do that, but again, it's a lot of overhead. It's up to you to decide if you want to do it. And finally, I'll just say that this talk is a summary of actually of this article that is written, and you can go and read in depth about everything I talked about and see all the comparisons and the code itself. So feel free to go and read that on your own. And with that, I want to say thank you very much, and don't forget to do schema validations on your Kubernetes manifest files.
Thank you so much. That was great. I mean, even I understood bits of it, which is, surprising. I was going to say, actually, it was really frustrating to watch, because I was saying to Brian, like, oh, I'm going to ask him this question and this one. And you just kept answering them with your own slides. So, but one of the things that I noticed is that, you put on the last slide a link to like a deep dive on schema validation and everything too. I imagine that it's something that, developers may struggle with initially, or that barrier to entry is quite high. So would you say that that link that you put at the end of your presentation is the best place for them to start off when it comes to schema validation? Or are there any tools or resources elsewhere that you'd also recommend for people starting up with schema validation?
If you go to Google and write Kubernetes schema validation, you will get this article first anyway. But I also sent a link to it. It's a great article. We wrote it for the community, both in our blog and in dev too. It's an in-depth comparison that my co-founder and chief product officer did, because it was really important for us to go and understand what are the differences and why isn't this solved on kubectl level. And the answer is very simple, is because kubectl talks to the cluster, and you want to shift left, and you don't want the developers to talk to the cluster. So it's like different use cases, and then it makes sense why there are different tools.
Excellent. That's absolutely music to our ears. Well, thank you so much for your time, Shimon, and it was a great presentation. We'll hopefully see you on stage here again in the very near future.
Thank you very much. Bye-bye.
Bye.